Hello everyone and welcome back to another Universe Sandbox video, and today we're going to be doing part 2 of evolving our latest custom solar system from birth to death. So last episode we formed our system and we have ended up with this. So far not too much has changed as we only ran it briefly. The inner solar system on the other hand has got a gas giant in a retrograde orbit going the wrong way around. I'm sure that's going to have some consequences in today's video as well. And I'm sure the inner solar system in general probably is going to have the most action as this system takes place as well. As for the star, it's a 4-mass star here, and as pointed out by Total Anarchy in the comments, this is technically going to be an A-type star. So we're going to be going into the blue levels of temperature today. So 10,000, something like that, 10,000 Kelvin. We'll make it a blue star. And then they also said as well, this will have a slightly different red giant stage as well, which is a good point. So yeah, where do they say? So it says this will move to a red subgiant stage after being its normal A type in the main sequence. Then it will have a blue loop instead of a helium flash, so it'll go blue red a bit. So it should be interesting. This one will not nova as well, which is an interesting point. So yeah, should be interesting. And this will go to a white dwarf as well. So yeah, we'll go with that. That's a very good point they put in the comments here. Thank you to the comment, Total Anarchy. They're very knowledgeable of their stuff. I see the comments all the time as well. So yeah, very nice point indeed, and appreciate it. So without further ado, everybody, let's get this system rolling. So let's let the system evolve for a bit before we start increasing the star's brightness here. Or it's actually increasing on its own, look, as time goes on. But yeah, I want to make it into the blue star levels today. It's got the mass for it, so yeah, it should be good. But yeah, orbits, you can see there's a few little bits of wobbles there. But I think we have quite a decent gap in the outer solar system, so we'll have to see if that... No, there is a bit of a wobble though, isn't there? And we do have... Oh, there you go, so something's gone already, and that was a potential live candidate as well, which is a bit annoying. So we've lost that green object. So yeah, the inner system is having a bit of carnage, as we can see here. Yeah, I think the inner system's definitely going to be under some trouble. I mean, that warm Neptune in there, the purple one, another ejection. This object here, going in that retrograde orbit, it's a bit dodgy. There he is. So yeah, that warm Neptune there. Definitely going to be causing some issues with that retrograde orbit it's got going on there. So, oh yeah, so definitely the main problem causer here. So we lost this world here. Unfortunate, but that one is gone. There's a lot of fragments being slung out. Was there a collision or something? I don't know. Looks like something went down in the inner system. Where's the other objects being ejected? That has gone as well. Yeah, that one's not coming back, is it? So bye bye. Okay. Let's continue with the evolution. Very good. Okay, but so I mean, as for the outer solar system, things are staying pretty calm so far. Maybe we'll have to do something about that, but we will see. So there we go. But yeah, while that's all playing out, star itself still slowly increasing in temperature, isn't he? So I wonder when will that peak actually? Let's turn off the goggles as well. So you can see right now it's more of a white star, but it's still things are only just getting started as that temperature does increase. So we'll have to wait and see on how that does. How large is it in size as well? It's not even a sun size yet, is it? Yeah, it's only okay. We'll have to do something about that as well, because this star, in theory, it should have grown by now. So we are definitely going to increase that. But the temperature's still slowly, rapidly increasing, so let's see what we can do. It looks like we've lost another object. So another potential life candidate, of course. So that's gone. So the inner system is really clearing out a lot of orbits in that region. Okay, but yeah, while that's slowly going, let's actually just manually buff the star bits. We'll go in with a cheeky save, get that all thrown in. So there you go. Right, so size-wise, let's put it straight to, I don't know, 1.1 suns or something. So it's already bigger than the sun. 1.2. Why not? Make it bigger. There you go. Now is the temperature going to continue to increase? So now it's going to decrease. So I'm going to increase the luminosity to 2. I want this surface temperature higher. So let's try 8,000. How does that? So it puts it to 5 luminosity of sun. I mean, it is an A-type. It's not going to be your friend, the star, necessarily. You know, it's going to be a lot brighter. So 8,000. Still not all blued out yet, so it does need a little bit more, but we will get to that. So there you go. So you can already probably start to see some big changes in this inner region here as the star. This star's a rapid evolver, so it is going to be getting in there a lot quicker. So there we go. So right now, this world here currently got oceans, but we've already passed the perfect point for it as the stars got older. So there you go. But yeah, currently got oceans on it, but that probably won't be around for too long. This world as well, same deal. The warm Neptune here, almost at 100 already. There you go. So 11 degrees on here, but yeah, this star, this system, you know, it's not ideally going to be the most habitable system with the A-type. So There we go. And then these worlds out here, not sure there's much going on with these. This one here, potentially, I think is probably your best bet now. This green atmosphered one. What's it called? It's composition of... Oh no, water on it though. So no potential chances there either. Okay. This may be a system that was doomed. Losing all of its... because obviously all the good stuff got ejected, so... That's an unfortunate case of events here. This one's got a very high greenhouse, hasn't it? I remember we noted it as a red object in the last one, didn't we, with the trail. Oh yeah. So that's pretty warm. Okay. So we've got these worlds out here, the gas worlds. Still not too much going on out there, is there? Okay. And these guys are all chilling out on the edges. Okay. But yeah, no, all the potential good worlds have already been kind of thrown away. So, there we go. Let's continue. So, currently at the 8,000 mark. So, instead of increasing the size and stuff, we'll do the temperature next. Okay, so still seeing a bit of wobble. What was that got thrown out? Something else went. Where is it? Oh, wow, that really got slung out, didn't it? So, that world is gone. That world was quite hot at one point as well. Look at the temperature on that cooling down. That's how that's gone. Okay. But yeah, it looks like the distances between these worlds, you know, are pretty decent at the moment. There's not really much going on in the outer solar system here, so it looks like we may need some kind of interstellar traveller just to change things up a bit. So, okay, yeah, I think we're going to have to go ahead and do that, because we are not seeing many changes in the outer system. We want a bit more drama in here, so there we go. So there's the dominant gas giant as well. But yeah, it's not really interfering on much in the inner solar system, is it? It's just sitting in that position where it's not really too much. The next gas giant out as well, I mean, there's not really much changes here either. Then further than that, the ice giant worlds. I mean, there's, again, not much. This object had a slight one, this green one, had a slight bend on its orbit early on in the last episode. But yeah, this time there's not really much going on out there. Right, so as for the star as well, we'll pull it up to the 10K now. There you go. So again, the luminosity rapidly evolving 12 now. So that now probably is pretty much in the blue, almost in the blue star phase there. There you go, so slowly decreasing a bit, but I mean it's at that level. So there you go. Right, so let's continue with the evolution. Again, yeah, the orbits, I mean, wobble, but that's about it. Everything's staying fairly placed. So how far away is the furthest object? So that's sitting at 200 AU. There's big jumps between these last few worlds out here. 1,000-year orbits going on there. The main gas giant region here. Nice giant region, so... Yeah, these are way further than Neptune distances. I mean, it's pretty huge. I mean, this here is basically Neptune distance. A gassy banded one here. This one's more of a Uranus. This one's Saturn-esque. Yeah. Then this one's also in the Jupiter position. So basically this is your Neptune, and then everything out here is just way further away. So looking at the distances, I mean, everything is pretty much where you'd expect it. Comparing it to our own solar system, it's kind of come out that way, isn't it? So, well, that's all playing out. Again, the inner system, there's not too much. I reckon there'll be more ejections at some point. But you see the orbits are kind of calmed down now, actually. Look at that. So, yeah, everything's sitting fairly well placed, despite there being some weird orbits going on. Oh, this object is getting absolutely savaged, isn't it? Look at that. 2,000 plus there. Oh, man. There we go. And then these guys are all in the high ones now. 176 on our warm Neptune. 800 there. Yes, the inner system got wiped out real quick in this one. All the good worlds were just eliminated straight away, ejected, and then the stars just rapidly increasing. So, yeah, not particularly fun for these guys. So, while that's all playing out, like I said, let's have a little bit of a close star encounter and see how that shakes things up. So, what star should we go for? Ooh. Normally I do a red dwarf or a brown dwarf, but I'm thinking we have a full-on star this time. Let's go with... I'm going to go with Alpha B here. Alpha Centauri B. So that's an orange type, isn't it? So let's do it. Yeah. There we go. So the K1V star. Yeah. Let's place that in. So let's go ahead. It is a K, isn't it? Is it the game? Yeah, K1V's type. Okay. Right. There we go. Very good. Right. Now where do I launch it from? Let's have it come from deep space. So where are we? So let's plop it roughly directly there. So Alpha Centauri B. So we're having an interstellar encounter with Alpha B. Let's see how that plays out. So that star alone, 0.9 suns. Our own star is 4. if it has a close encounter, that could really cause some orbital problems. So let's go ahead and plop in a save before all carnage unlooses, and let's see how this works as the Alpha B star approaches. And hopefully it doesn't wreck the whole thing, but I want some kind of orbital change in this one. So there we go. So the star's approaching from deep space. Maybe I've launched it too direct. Let's see how it does. So you can see immediately it's starting to ruin orbits out there, ejecting stuff as well, because it is a pretty decently sized star. But will our system survive this? So I don't want to wreck it too much. But there it is, Alpha Centauri B flying around. It looks, oh, if it actually collides with the star, that won't be, it looks like it's going to sling past. Okay. So, oh, that's going to cause huge problems. That's a mass of an entire sun there. As it slings around, it's going to absolutely trash our orbits. We may have broken the system a bit too much. It stole a planet as well. Look at that. I think we've completely trashed it, haven't we? That can happen, though. I mean, it's not out of possibilities for this sort of instance to happen. So there you go. And that actually trashed it. I think that was a little too much, though, wasn't it? But it did steal a planet. It stole the warm Neptune. Oh, dear. We have to change the course of it and have it sling by a little faster, I think. But there you go. So that's a one potential scenario. But we're going to reverse that because a bit too much for my liking. It's kind of left us with no system left to evolve. I mean, if we just evolve it briefly, actually, you can see it now. That's caused massive instability. I mean, the dominant gas giant is now slinging into the inner system a bit more, so eventually that's just going to completely... All those elongated orbits, that is going to absolutely trash all of those. So... on the Alpha B star will just fly away again. But yeah, that caused absolute... Look at the mess it caused. But let's go ahead and rerun that scenario. So what I'm going to do is I'm going to shoot the star at a different trajectory, because I fired it too inwards, didn't I? I'm going to fire it at a higher speed as well. So let's go ahead and remove that. Let's go back over to it. Right, so let's go ahead and delete that before it starts causing problems. Right, I'm going to relaunch it, but I'm going to increase the launch velocity as well. I'm going to have it as a almost like a shooting star, and actually have it coming in at quite a high speed compared to what it was before. So where are we? So Alpha B. It's always fun to do a few scenarios, but I've got to find the one that I want to keep and stick with. So where are we? I just completely lost sight of Alpha B. Where is it? Right, so let's fire it at a different trajectory. There we go. I want it brushing alongside the system, not completely going into it. So there we go. So that's on a different course. That's more like it. So there we go. Right. So Alpha Centauri B, a close stellar encounter, but nothing that's going to completely wreck the inner system. So I don't want it flying too far by. So let's see how this causes. So our scenario 2 of a shooting star from a nearby pass. There you go. So it does cause a few instability orbits. There you go. So I think I may stick with something more like that, because that's now changed the orbits of it. So that could cause the planets to interact with each other a bit more. So that star flies off. So that's our potentially first of many stellar interactions in the system, depending on how this evolves. So there you go. So now we'll go ahead and get rid of Alpha B. So there you go. So its job has been done, and it has slightly caused some of our orbits to go skew with a bit. So now we can see there's a few more of those orbits slowly wobbling around. So let's see how the system adapts to that star causing a bit more wobble. Is it going to affect our orbits? Yes or no? We'll have to wait and see. There we go. So slowly brushing on the outer edges of our system there, but definitely going in between some of the planet orbits, which definitely could have some consequences there. Okay. The inner system, though, still some changes going on there. You can see the orbits are slowly changing over periods of time. It looks like another one's been ejected, but yeah, with that warm Neptune in there. Oh, speaking of the warm Neptune, I think we've just lost it. Oh, that's an interesting one. So it's actually been ejected. So that may have cleared out our inner system a bit from potential problems. Very, very interesting. Okay. Ooh, some of the orbits are slowly... still slowly changing there, so there we go. But while that's all happening again, star, I'm going to continue with its brightness increase and surface temperature increase. Let's go up to 12,000. That's more in the blue spectrum type now, isn't it? Something like that. I think we'll stick with that. 26 luminosity as well. There you go. Size-wise, I'm going to buff that as well. Let's put it to 2 suns. That may decrease our temperature a little bit. There you go. Okay. Right, so where did that... That's completely gone. Yeah, that's long gone. That's gone as well. And this star, I'll see with that power. technically it's going to erode atmospheres a lot faster than other types of stars as well. So there you go. Pretty good though. Let's see how that continues now. But again, there's still not much. The outer solar system is quite a calm area still. There's still not been too much going on out there, is there? The dominant gas giant hasn't really done much effect since everything is a decent distance apart from each other. Plus, the star has a stronger pull than other stars. I mean, if this star was one massive sun, we may have seen a bit more in the outer system. But since this is 4, it's got a lot more influence than the stars that we'd normally do in this series. So definitely more interesting in that regard. Right, so where are we? Oh, that world, 3,000 in it. That greenhouse on this one is just, it's just constantly losing material. What is it even made of? Yeah. Ew. This thing has been absolutely trashed from day one, really. It's just not had a good time at all. This is one I think had a lot of collisions, and it picked up a lot of material. It's just constantly spraying material out. If we turn the goggles on, are we going to see it a bit more? Look at all that. Oh, it's just constantly shooting it out. There you go. If we just slow down time, you'll see it a little easier. There you go. Goggles on or off? Oh, yeah. Oh! Look at that. All that mass ejection on that. Just constantly spraying out material. There you go. And even here, the star's not that big. Just a crazy greenhouse effect on it. Just absolutely ruining it. Oh! What level even was it? Oh, that. Oh, yeah. Oh, 1738 ATM. That is brutal. How many layers has it got? 4,000. I think you can only normally put this to 1,000. So this thing has just gone absolutely crazy global greenhouse there. How are we doing on the other inner planets? So 1,000 there, 500, 500 again. So they're just completely ruined. Where is the warmth reaching at the moment? So this green world's still not in the temperature yet. 4 degrees. So this is sitting on the edge of the habitable region. But again, this star will be a rapid evolver. So again, let's continue with the brightness increase and stuff. So radius we're going to tile up to 4. And temperature. How's that going to affect our... Let's go luminosity. Let's go to, I don't know, 35? That may decrease our temperature a bit. 4 radius of sun, so you put that in AU. So nowhere on the big scale yet. Slowly losing a bit of temperature though. There we go. Right, how are we doing? What was that? I got ejected. Let's delete that as well. Oh yeah, that's long gone. Okay. Dominant gas giant. Really not put much of a show on it. But again, yeah, I think I put the orbits quite far from each other. Plus, the, like I said, the higher mass star having the stronger pull anyway. Yeah, the dominant gas giant's not really had much to do in this one. It's caused no effects on anything. If we had another gas giant between this and then the next one, we may have seen a bit more carnage. But there's been nothing. It's been an absolute, pretty dead show, hasn't it? In the outer solar system, the inner system's just been carnage. The outer system's been the complete opposite. There you go. Okay. The inner system's orbits are just constantly battling it out for position. So again, let's just speed things up. I'm sure we're going to see more ejections as time goes on. Oh yeah, you can see orbits are still changing in there, bouncing off each other. And the blue, I reckon the blue or the red one. I reckon the blue one first. This one may be the one that gets slung out. I mean, this was a potential life world at one point, wasn't it? Yeah, I marked it blue. But it's just stinging way too close to the star. Unless it can find a position further out, I think this world's going to be doomed. Yeah, it doesn't even cool down enough at that position. Oh, dearie me. Right. Temperature just doesn't want to... Oh, yeah. So, yeah, I think that stellar encounter did upset some of those outer objects, didn't it? Some of these, I mean, some of them are full-on super Earths, and these aren't just dwarf planets. These are full-on planets, but none of them have any good material as of yet. I mean, what's the composition of these things? So, and it's only frozen hydrogen. If this one has methane, nitrogen, I mean, that can potentially warm up, have an atmosphere at some point. Carbon dioxide. So potentially this world here. Let's actually mark that one because that one actually had like it had a good composition. So this world, put it in green. So let's go back to that composition. So it's got oxygen, carbon dioxide, water, nitrogen. If this warms up in the future, this potentially could have something going on for it. Let's just go through them all. So that one, only nitrogen. Methane, hydrogen again. Nitrogen, what's this one? Some of them have similar compositions. Yeah, a lot of them are quite similar, aren't they, with the way we plot them in. So there's only one chance for a potential decent planet in here. And other than that, everything in the inner system's already too past. The rest are gas giants, ice giants. So that is the only chance, is Bono's here. The only potential world. If it gets a bit of warmth, it may be able to do it. So hopefully we'll be able to get to that. It's a smaller world though. Look, it's what's that in? So masses. I mean, it's a decent enough size. I mean, it's bigger than Mars size. Does it have magnetic field? Did I give it a magnetic field? It doesn't have one. Okay. We'll see how that plays out. I mean, I did give a lot of the inner world's magnetic fields, but they're all ruined now. Oh dear. Okay, so star's gone back down to 7,000. Luminosity 35. Right, I'm going to start doing a bit more rapid evolution. Because remember, this star will age faster than our normal G-type sun-like stars that we normally do in this series. So I'm going to double buff it and everything. So I'm going to go to 8 suns. Luminosity I'm going to put to 70 now. See how that affects. I'm guessing temperature will drop more, so it starts to go a little more red. Yeah, okay. But like Anarchy said in the comments, you know, it'll go through the blue loops. It'll go hot, cold again. So we may have to... We'll try and simulate that. But again, I can literally just increase the temperature here, and that probably would do it for us. So there you go. Okay. So again, how's our world out here doing? I mean, it's still receiving... I mean, the zone is nowhere near the sky yet, since it hasn't formed its atmosphere or anything, since it's too cold. So we're going to have to see how that does. But I think when the light reaches it, and it starts to really feel the heat, it may just go too hot straight away. We'll see. There we go. But again, let's continue the evolution. So a bit of wobble out here. This blue ice giant's a bit of a concern, because if this gets too close to our green Bono's planet, that could upset this orbit a bit. I mean, let's just look at its orbital. So the orbit is slightly being changed, isn't it? It's not perfect. And it is sitting between 2 gas giant orbits as it slings in its slightly eccentric orbit there, so it is at risk of being affected at some point. So that is the Achilles heel. It may have the nice potential composition underneath it, but it just depends if it can hold on. That is the question. So there you go. So our system's still slowly wobbling around, isn't it? Inner system, I mean, the temperatures in here, I'm sure are getting wild. The orbits, I'm sure one of these is going to go. My money's on the blue one still, because its orbit did get bent a lot more earlier. The red one's still sitting in a bit of a wild spot as well. You can see it this orbit as well, whereas this one with the green atmosphere, just mark it a bit more as well so we can see it. That one's orbit slowly wobbling around if you look carefully, if you look at its stats here. This one's constantly changing. I think that's probably the pull of the dominant gas giant doing that. There must be. So that, in theory, could be eventually ejected as well, or picked up by the dominant. It could just get a little close at one point, and that could be it. It's having a wild wobble, isn't it? It really hasn't found its keep at all. It's really just constantly changing. The blue orbit just changed in the inner system as well. All these things take time, and that's what this system's all about in this series. It's watching it evolve over hundreds, thousands of years. I mean, look at our simulated time. 0.02 million years of simulated time. So no, we're getting this system on a bit. Orbit really doesn't want to settle, does it? But yeah, dominant gas giant's definitely got an answer to that. Let's see how. Can we go any faster? Yeah. But the faster we go, technically, the less realistic the orbits can be, as the game's got to simulate stuff faster. Oh, something else has gone there. Wasn't one of the worlds that we marked, though. It was just one of the random inner planets. So, I've lost that one. Oh, we've lost 2, actually. There you go. So we've lost that one. What was this? That one's long gone as well. Another world's escaped. Okay. Let's continue. The inner system's slowly being cleared out. We did have a lot of planets in there, though, granted. So, I mean, it makes sense that a lot of them eventually go. Looking good. But yeah, that inner system is definitely... This has probably been the most carnage inner system we've had for a while in these series. Normally, the outer system sees more changes with giant gas giants and their masses, but this time the inner system has been more of the one to watch. All just depends how you build that system. It really does make the difference. Still that green orbit still wobbling around, but yeah, while that's all going on as well, I think it's time we go for a save, because we haven't done a save in a while. So there you go. Let's override that. I think the star as well, we're going to continue. So what I'll do is I'll try and double it up back to... And we're not properly in the red... Would this be red giant worthy yet? I mean, it's 8 luminosity. I mean, maybe we do that blue loop thing then. Let's try and... So I'm not as familiar with A-type progression. So let's go... I mean, yeah, we'll double it up. See how that does it. So let's go it back to... Oh, yeah, doubled it. Oh, the luminosity rapidly went there, didn't it? I mean, how far's that gone out? Oh. Huge luminosity jump. So if I was to half that again, does it just go back? So it does, yeah. Okay. Interesting. But yeah, A-type star, pretty wild. So let's actually... What I'll do is I'm going to increase this to... let's double it. Let's go 140. So the temperature's going up again. Slowly getting a little more blue-white again, trying to simulate that blue, the blue loop. But it may be hard just to cool it down with our game limitations, potentially. But you know, I'll give it a good shot. So there you are. Size-wise, let's go to 10 suns as well. So obviously that decreases it again. So they're all working against each other, these stats. 140 luminosity. This world here is still nowhere near the reach of the star yet. The star needs to be proper huge, I think, for that point. Near the end of its life. I think the inner system stuff, though... I mean, how's our red world doing here? Is it lost its house here complete? I think it has. Yeah, this was at thousands, hasn't it? I think their atmosphere has been completely wiped out. Oh dear. So now it really is just a scorched rock. Yeah, that used to have an atmosphere at one point. It has been erased. And yeah, I think that's what we're going to see. We're going to see a lot of mass loss from a lot of these. Magnetic field. Interesting how that was changed. Look, it's increasing. Where is it? Let's go now check it out. Show magnetic field. Yeah. It's changing. Look at that. Is it? Yes, as it gets close to the star, it loses it. Interesting. Very interesting. So again, let's have a look at that magnetic field. Struggling against the power of the star, so it decreases in size as it goes closer. Look at that. Interesting stuff. Hanging on there. That one has no magnetic field. This one has a magnetic field. Yeah, that's changing as well. Interesting stuff. I think I gave the gas giants some, didn't I, as well? Is this one? Yeah, this one has a huge one. Look at that. That's right. Yeah, I did give these guys magnetic fields. Switch them on. Yeah, I gave them all, didn't I? Okay. Very, very interesting. I'll turn them all on now. You can see, yeah, they're over there. Okay. Again, let's continue the evolution. See those orbits change. Okay. But yeah, since our rapid evolution, yeah, we're definitely this is definitely a quicker star evolution process than we normally do in these. I mean, this is border red giant kind of levels now. I mean, yeah, definitely, yeah, 10 luminosity. Yeah, that's definitely red giant phase for me at this point. I think, yeah. There we go. Okay, the orbit's still batting out over there. I'm still concerned that Bono world's not going to get its chance. I really hope it does, though. I mean, the outer orbits are mostly behaving themselves. Let's just go to it, actually. Let's just see what's sort of... So the other one's... So that one's a little more inclined, isn't it? Hopefully they won't interact. It's just the blue one, the blue orbit. Again, it looks on a very similar eccentricity to the green one. Yeah, hopefully they won't meet, though, because there's a few points they could. Okay. So if I was to start increasing luminosity, it does affect how... It doesn't let me do it too much, so it keeps resistance. If I do luminosity... So that increases the temperature more. Okay. So slowly rack it up. So I guess this is the first of the blues. So it's gone back to 10,000 now. So I guess this is our little blue loop a bit. Somewhat. So shifting from red to blue, increasing luminosity, and it will only shrink slightly. So I haven't simulated any shrinking yet. 900. But again, our Bono world still not there, is he? Well, it is starting to warm up though. So eventually, if we can get any of that carbon dioxide can become gas, start building an atmosphere, we may see something. Has it got any atmosphere yet? It is. So it has got something going on, but it looks like it keeps refreezing. So it is trying to build an atmosphere at the moment. So we are slowly getting there. It's very thin, but it is building. Interesting. So we're starting to see a few changes there. So 900 luminosity. Again, let's increase the size of the star. Let's go to 15 suns. So again, that drops our temperature down again. Okay. So what's that in AU levels? Are we anything substantial yet? No, still not really, is it? Okay. At 900. Turn the goggles off. We're going to start seeing the real brightness of Helios. How's the star looking from the furthest of the planets over here? So you can see there's a few changes here, though. Look at that. So it's still darkness over here. Turn the goggles off, you see it. So what's going on here? So there's that. I'm guessing that's liquid nitrogen, yes. Okay. So even at the furthest point, there is some changes going on out here. So we're starting to get little lakes, rivers of liquid nitrogen forming an ocean. So even though not water, still getting an ocean of some kind. Let's look at the other worlds as well. So this one's still too cold, not much going on there. Nothing here. This world. Oh, it's got some clouds that have appeared. Hydrogen, yeah, not hydrogen or nitrogen atmosphere. So it is building it. I mean, it's not showing it much. To zero, does that show a bit more? Not really seeing much on it. It has got an atmosphere, yeah. Okay. It's a little bit of customization for it. What's going on over here? So again, this one. Ooh, yeah. So it's mostly nitrogen atmospheres now, but again, it doesn't have the water to really. Let's make it like Titan, maybe. There you go. It just says a bit distinguish between them. So the effects are reaching the outer objects now. But again, Bono's is the one I want to look at. So it is building it slowly, but I'm not gonna. I want to see it naturally do it. It has got the stuff. It literally has the stuff. It just needs a bit more to really get in there. So again, Helios. Let's continue with the increase. So let's try to into 1/200 suns. That's gonna. So I'm not sure how I can drop the temp. I think if I make it bigger, the temperature will drop more. So let's try 30. Yes, it's dropped down to 6,200. We're not really going ultra red yet. I mean, I'm trying to simulate it as best as I can with the game, but I think that's obviously if we change one stat, the other stat changes, so it's a little hard to try and get it in the perfect point. But again, it is a fantasy system, so we're not fully realistic. But no, we're taking a lot of inspiration from the A-type star evolution on this one. So yeah, take that with a grain of salt. But yeah, hopefully you're enjoying this different star evolution, because we've never done an A-type really, or like properly focus on doing an A-type. Normally we just do a G-type. Is the ones I normally go for, or I just go for some massively crazy star. It just goes into like super giant phases and stuff. But you know, this one I'm trying to go for a little bit more. So yeah, let me know your thoughts. You like these ones more? Should we try other types? I mean, I'll try and do them as best I can. Yeah, we'll see. But I'm not as familiar with, like I said, with the A-type. Not as familiar with their evolution phase. I mean, I have seen pieces of it, but if you ask me, I wouldn't be able to write it all down for you, for instance. But yeah, I know somewhat. I mean, I'm not a complete spanner with it, put it that way. But yeah, there we go. Right, so let's keep going. But yeah, I really want to see that Bono's object. Yeah, let's continue more. So let's go to 1/400. We should start to see. Come on, a little bit more. How are we looking here? So carbon dioxide. There's a bit of gas that is slowly. Oh, there you go. Yeah. But it drops again because its orbit goes further out. Ah, that's the problem as well. Its orbit does make it a little more tricky. The inner system though is definitely going to be feeling the heat here. 1400. Again, let's go over size increase. Let's go up to. Oh, I really want to double it. Let's slowly creep it up more. And it's gonna. Yeah, the first world here is going to be engulfed at this point. It's not got long left, as we are starting to go to the red jet. See, the temperature's really dropping now. 0.2 AU. Yeah, we're getting places. That reminds me, one thing I need to do is disable the particles, because I don't want the starlight just doing that weird thing it normally does. So turn off the fragments here, because I don't want them messing up the star size. That's the fix I found for it. So there we go. Oh yeah, one of them just fell in. Yeah, with its eccentric orbits. We lost the blue orbit's completely gone. Falling into the star. Oh yeah. As we slowly creep up more. Oh yeah, a little bit more. That last orbit is not going to be going much longer. That's pretty much it. It's brushing right on the edge of things there. Let's try and catch it in its... There. Ooh, right on the edge of it. Oh yeah. There you go. That's pretty wild. pretty good. Okay. Oh yeah, that's certainly getting there as well. Okay, so once we've done the blue loop stuff, so I kind of say we've probably kind of fast that phase a bit more now. So we need to start doing the giant branch where the star grows and shrinks repeatedly, kind of like the sun technically could do. So yeah, okay, we'll see how that does. So we need to start making the star lose mass at some point as well. So we'll keep that going. But what I want to see first is I want that Helios object because I mean luminosity's. We can go a little higher. Let's go to let's try 1700. So that's going to change our temperature a bit more as well. Still not quite there. It is warming up though. It is slowly starting to get there, isn't it? But it's that further out orbit that still kind of comes back to bite it. One thing I will do as well is as we are starting to get there, I'm going to actually drop this to 3.99. So that is going to slowly lower its release on some of those orbits. There you go. Luminosity, let's start really rapid evolving it. 2200. Size-wise, bigger. There you go. Origin over here, minus 100, so still just slowly coming in there. But yeah, that eccentric orbit has really cost this object a really good shot at this. And it's, of course, it is still quite far away, so it's not in the best attempt. But luminosity again, I think it can probably surpass 3000 here, because I think our sun's only. I don't think our sun's going to go much higher than that, potentially. But yeah, I think for an A-type, I think we can probably go a little more bright than that, because I'm probably not doing it justice with the brightness. So I'm going to go to 3.5. Let's go for a huge increase. Let's see how that does. I bet you that's probably overdone it, but let's see how that does it. Or is that enough? It's starting to get in there, isn't it? Maybe that'll be enough to start doing it. We'll see. I mean, the carbon dioxide is... There's an atmosphere there. It's the water that's still frozen though, isn't it? 14%, or maybe not. See, there's a few changes on it. I mean, you can just increase the atmosphere, but that doesn't really do much. Looking underneath, it's still mostly frozen. Further out, having over here. And this one here, the frozen. Little patches on it at one point, wasn't there? Inner system, on the other hand, is not really going to be seen too much more. So again, let's double it up more. That's going to engulf the next objects. There you go. They're gone as well. 0.777 AU. But again, this guy should be getting a little bigger than that 1 AU mark, I'd probably say. We need to lose more mass as well. Slowly losing its pull on objects. And then it slowly needs to, you know, do the shrinking thing in the late giant branch. So let's slowly, you know, increase and decrease, but that's annoying, it changes our mass, so let's just, there you go. So it's kind of like this kind of effect as it loses mass in the process as well. I mean, I know of this, I normally just don't do it just because it's a bit more complicated, but for this one we will do it. So there you go. So I've seen loads of future solar system videos where, you know, you see the sun go up, down, up, down, up, down, and then eventually it just pops as it loses mass. But for this one, let's see, yeah, that temperature's really decreasing. It's eating up another object there. Luminosity, let's go bigger ITER. Let's go to 4,500. Mass loss as well. Let's continue with the mass loss. And eventually it will just go all the way down to the white dwarf at the end. So there you go. 1.1 AU on this guy now. So Helios, proper bright. Proper red now at the 3000. Where are we over here? Now surely, is this enough? It can't, surely at this point we should start to see some kind of change here, but it still just goes too far away. That's the problem. Look at its orbit, and also since the stars lost mass, the orbits are getting a little more eccentric as well, which is very disappointing for these objects. As it slings by, is it enough to really get it going? Oh, it just doesn't want to do it. I think it's just too far away to really, really get it. It's just brushing on that 0 degree mark as well, which just is not enough to really get it going. Let's just try and catch it in the moment. As it goes into this region here, look at that temperature slowly go down. It does go into positive 20 there, almost. But it's just not enough to hold it with that orbit. Which is right. Look at the star. Whoa, look at all that. What is going on there? Yeah, I mean, the star is pretty angry. Yeah, that's quite wild. So let's put the goggles on again so we can actually see him. So again, we can do the simulated thing as the orbit changes. So that's why I don't normally do this, because the mass keeps unlocking and stuff. It's a bit of a pest. But there we go. But again, the orbits are being trashed no matter what anyway. So going up to maybe 2 AU, and it shrinks down again. And as you see, the temperature changes as it does this. So it's going to eat that planet up as well. And then it's going to continue to lose mass until it just can't do the fusion no more. And then it'll become a white dwarf. So we'll continue losing the mass as the star loses its pull. Size it is decreasing as well. Luminosity and stuff as well. But yeah, this star slowly losing its size. But again, it buffs up more. And I think once it reaches to its absolute limit, then it's just going to eventually pop down to the white dwarf. And there you go. So eventually it's going to... The orbits are completely ruined at this point with the star losing so much mass. And their orbits are pretty trashed. So again, let's lock that. And I think it has one final grand hurrah. That's a little too large. Luminosity again. Probably can go up a little higher as well. 5,000. I think that's probably peak size. I don't think it can really do much more than that. But again, a lot of the orbits are kind of ruined anyway. And then we'll go ahead and do the usual process of replace it with the white dwarf. To simulate it, plop it in there. And it goes, lost its mass, 0.89 suns. And I think that's mainly it, isn't it? And everything falls into cold and darkness. But I don't, you know, with the star losing so much mass, that its orbital, a lot of the orbits on this guy, kind of ruined. But there you go. I mean, this one only has 0.89, for instance. So I mean, technically, maybe it'd have a bit more, but there you go. And I think, you know, something like that. I mean, that's my attempt at the A-type evolution. I mean, let me know your feedback down below. I mean, I haven't properly studied it, but, you know, going from what Total Anarchy said in the comments there, I've given it I'll try to give it some justice there, so there you go. Let me know, give me your feedback on that one. What do you think of that? But, yeah, I hope you enjoyed it. We've done this one in 2 episodes, but yeah, with the more rapid evolution. There was less objects to really focus on without any Earth-like ones as well in the inner region. They all got ruined, so yeah, without them really in there to change much, we can evolve the stars as since there's less worlds to focus on in particular. So there you go. But there's still a few objects. Or one. Is that one object holding on there? Yeah, literally just one left. That somehow managed to survive. And it was that green world. There you go. The world had all that instability near the dominant gas giant. It's the only world still standing. Look at that. There you go. But again, not much temperature there. But yeah, hopefully you enjoyed it. So yeah, the red giant phase of that one. So it's the asymptotic giant branch. I probably completely butchered that pronunciation there. But yeah, with the star puffing up and down until eventually it can do it no more. So there you go. But yeah, let me know your feedback on that one. Keen to hear it. Hope you enjoyed this part 2 of this system as well. And yeah, let me know what we're going to see in the next birth of this system as well, everybody. If you enjoyed this live one, make sure to press that like button. Let's see if we can go for 100 likes on this one. Also subscribe if you're new. Help us on the journey to 50,000 subscribers, as we are below 2,000 on the way to 50. We are so close for it. Really appreciate all your support as well, everybody. Means the absolute world. And yeah, keen to see what you guys suggest. But yeah, that all said and done, everybody. Make sure you have a great day. Stay safe up there. And I'll see you in the next video. Goodbye.